Last lesson used strings for single values, counters, and whole JSON blobs. Hashes solve a different problem: flat objects with many fields. A user profile, account settings, or shopping cart quantities fit naturally. You update email or plan without fetching and rewriting the entire object. That saves bandwidth and avoids lost updates on unrelated fields. If you always read and write a document as one JSON unit, a string hash is fine. If you change one field often, plan, phone, cart quantity, a hash is usually better. Same Redis instance, different access pattern. Choosing structure based on how you mutate data is the theme of this lesson. HSET writes one or more fields on a hash key. For example, on the user hash, set name, email, and plan in one command, 3 fields created. Later, HSET again to add phone without touching the rest. HSET returns how many fields were newly added. Pure updates to existing fields may not bump that count. Check your Redis version if you depend on the return value. HGET reads a single field, for example, just the plan. HMGET reads several fields you list, in order, say name and plan. Prefer HMGET when a page needs a few attributes. Avoid HGETALL on huge hashes if you only need 2 fields. Read narrowly, write narrowly, that is the hash advantage. Compare with JSON in a string. To change plan there, you get the blob, parse, modify, and set the whole string back. 2 requests can race and overwrite each other. With a hash, HSET updates just the plan field. Concurrent updates to different fields do not clobber each other. That is why hashes are the default for mutable profiles and settings. Hashes store field values as strings, but HINCRBY treats a field as an integer counter. See to cart hash with product quantities. When the user adds another unit of the same product, HINCRBY bumps that field, say from 2 to 3. Concurrent add to cart clicks stay correct without locking in the app. HGETALL returns every field and value, convenient for rebuilding a small profile in memory. HKEYS and HVALS return only names or only values. HLEN returns the field count. On very large hashes, HGETALL can be expensive, similar to fetching a huge string. If a hash can grow without bound, redesign with smaller keys or pagination patterns. HDEL removes one field, for example email, and leaves the rest of the hash intact. HEXISTS checks whether a field is present and returns 1 or 0. Deleting the last field typically deletes the key as well, so a key level exists may then return 0. Use field deletes for sparse optional attributes instead of storing empty placeholders forever. When a hash might contain thousands of fields, for example a giant sparse cart or feature map, do not casually HGETALL in a hot request. HSCAN walks fields in cursor batches, similar to scan for keys. Use it in migrations, analytics jobs, and admin tools. For user-facing paths, keep hashes bounded or model differently. Important limitation: time to live is per key, not per field. Expire on the profile hash expires the entire object. Every field goes together. You cannot natively say email expires in 5 minutes while plan lives forever inside the same hash without extra modeling. If you need different lifetimes, use separate keys or store expiry metadata carefully in the application. Decision framework: choose hashes for flat objects with frequent single field writes, profiles, settings, carts. Choose JSON strings when the document is nested, always loaded fully, and rarely partially updated. If you need rich secondary queries across fields, that still belongs in your primary database. Redis remains the fast-working set. Older tutorials show HMSET for multiple fields. Modern Redis accepts multiple field value pairs directly on HSET, and HMSET is treated as legacy. When you read existing codebases, map HMSET mentally to HSET. New examples in this course use HSET only so your muscle memory matches current docs. Ship these patterns confidently. User profile hashes with HSET and HMGET. Settings toggles as fields. Cart quantities with HINCRBY. Sometimes a rate limit hash with 1 field per endpoint. Always bound growth, set a key level time to live when the object is temporary, and keep field names stable for clients. Common mistakes: treating a hash like an unbounded database table, calling HGETALL on massive keys and user requests, assuming field level expiry exists, storing deeply nested JSON inside a single field and losing the partial update benefit, forgetting that HINCRBY fails if a field holds non-numeric text, model flat, bound size, and keep numeric fields numeric. Here is what to remember. Hashes store field value pairs under 1 key for flat objects. HSET and HMGET support precise writes and reads. HINCRBY atomically adjusts numeric fields like cart quantities. HGETALL is fine for small hashes. HGETALL is fine for small hashes. HSCAN for large ones. Time to live expires the entire hash. Next lesson, lists for queues, feeds, and ordered sequences.